Right, so just to briefly go over the RL time constant, very similar as what we saw with the RC time constant. Essentially, we can safely say that after 5 time constants, so 5 tau, in essence, we can safely assume that the current's going to be 0 amps, like so. As you remember, the current does oppose a change in, or the inductor does oppose a change in the current. So if your inductance goes up, your time constant also goes up. But if your resistance goes up, your time constant actually goes down in this case. So just a very simple, so you can kind of see the graph over time as it exponentially decreases. So one thing to note, or one example here. So if you're given two values of your inductor is 0.2 henries, your resistance is 20 ohms, you solve for that, your time constant is actually 0.01 seconds. But if you actually multiply that out, what you'll get is that approximately after 0.05 seconds, that should be 2 zeros here. So you should actually go all the way down to approximately 0 amps. Now, what that means is that even though all the current may not be dissipated completely, it's safe to assume that most of it is gone, and we can just assume that it's completely dissipated in this sense, in this case.